Okay, today we're going to look at mutually exclusive events and how that relates to probability. Let's just quickly review some of the key things that we learned in the first unit. So remember, if I say A union B, so union as the U, and that basically means or, so that means in terms of a Venn diagram, remember that was all of A and all of B and all of the overlap if there was any overlap. So or means everything, and then remember when we have intersection, like the word and, so if it's upside down, that means the word and remember that's just the overlap between the two sections. Okay, so what we're going to look at is, first of all, we're going to look at what a mutually exclusive event is. So if it's mutually exclusive, that means there is no overlap. So in terms of a Venn diagram, are two things, in this case just A and B, doesn't matter what they are, they would have no overlap. So that would be like something like I'm going to roll one dice and get a number on it, like a 3, and I'm going to draw a card. So you can't have a 3 and a spade at the same time, like there is no overlap between the dice and the cards. So that would be mutually exclusive. An example that wouldn't be mutually exclusive would be something like I'm going to roll one dice and I want to get an even number or a number greater than 3, right? That would have overlap. So you could have an even number, which is 2, 4, 6, and also 4 and 6 are greater than 3. So that would be overlap. So if they're mutually exclusive, that means we get no overlap. And if there's no overlap, the probability is, remember the word or means plus, so all we have to do is find the probability of whatever A event is and add the probability of the B event, and that's it. So let's do an example. So let's suppose I say we get the probability of getting a 3 on one dice and I want to get a heart from a card. Okay, so basically all we have to do then is do the probability of a 3 and then add the probability of getting a heart, right? To get both of them, you just have to do each of them separately and add the two together. So we'd have A or hearts. Okay, so the chances of getting a 3 on one dice would be 1 out of 6. And the probability of getting a hearts, there's 13 out of 52 hearts. Or if you could reduce that, it would be 1 out of 4. So that means then our probability of getting one or the other would be 1/6 plus 1/4. And you can do those on your calculator or in your head, whichever. And that would give us 5/12 if I do that right in my head. So that's it. So if they're mutually exclusive, the key idea is make sure there's no overlap, and if there's no overlap, just add the two probabilities together and you're done. For events that are not mutually exclusive, now that means there is overlap, so when you do the probabilities, it's a different formula, and that's where you have to add the A and B together again, but you just got to ask yourself, is there overlap? And if the answer is yes, if there is overlap, then you just got to remember to subtract that overlap. Otherwise, it gets counted twice. So let's do an example where I said, let's say we get, what's the probability? We get an even number on a dice, and or greater than 4. So our even numbers on the dice would be 2, 4, and 6. And numbers that are greater than 4 on a dice are 5 and 6. So you can see here the 6 would actually be overlapped for both. So if we were to draw our Venn diagram, we'd have 2, 4, and 6 in A, and 5 and 6 in B. That means 1 and 3 would be outside. So now if we actually do the probabilities using the formula, we would get the probability of A, so the probability of just getting an even, which is 2 out of 6, or 1/3. Let's leave it in 6 for now. So 2 out of 6. And then we got to do greater than 3, so probability, or greater than 4. Probability of getting greater than 4 is, there was 2 out of 6 again. Oops, I messed up. The first one we had 2, 4, and 6. We had 3 out of 6. And then greater than 4 is 5 and 6. That would be 2 out of 6. But you can see we've actually counted the 6 twice. We've counted in the A and the B, so that's why we have to subtract the overlap. So then we've got to subtract that, the 6, the 1 out of 6 on the top. So we have 3 plus 2 is 5, minus the 1 would be 4. So we have 4 out of 6 would be our final answer, and we can reduce that to 2/3. You can see 4 out of 6 makes sense because in our Venn diagram we got 2 numbers there, 1 has the overlap and 1 there, so that does give us our four possibilities. So when you're doing these questions, basically the idea is just add the 2 probabilities together and then make sure you double check, is there overlap? So if there is not overlap, you just add the 2 and you're done. If there is overlap, you got to add the 2 and make sure you subtract that overlap before you finish the question. Okay, so first of all, let's do a couple examples where we determine whether things are mutually exclusive or not. So quick reminder, so in this case, mutually exclusive, remember there is no overlap, so they have to be 2 separate things to get to be mutually exclusive. But then also complementary plays a part. So remember with complementary, if I said A complement, that means it was everything outside of A, and if that happens to be the same as B, then we'd say they are complementary. So what that would mean is if you don't get A and the only other option was to get B, then we'd say they're complementary. Okay, so let's do a couple examples just to sort of make sure you understand what's going on. So the first one, let's say if I said I'm going to roll 1 dice and we're going to get an even and odd. So what's the chances we get even or odd on a dice? Okay, so even, you'd have 1, 2, 4, 6. For odd, you'd have 1, 3, 5. We'd say those are mutually exclusive, right? Because there is no overlap between even and odd. And if you don't get an even, you have to get an odd, so that means they are also complementary. Okay, so that's the first one. So even and odd, if we did that in terms of the diagram, you'd have evens in one circle, odds in the others, and there would be nothing on the outside. It's either one or the other circles altogether. Okay, so let's do a different one. So let's suppose I do a face card. So you're going to draw 1 card out of the deck, and we want a face card or a club. So in this case, your face cards would be one circle, clubs would be the other, but there's going to be overlap, right? Because you can have a jack, queen, and king that are both. So in this case, we would have overlap and we'd have a little bit of both. So in this case, we'd say they're not mutually exclusive because there's overlap, and if they're not mutually exclusive, then they're never complementary, right? They have to be totally separate to be complementary. Okay, so you can have mutually exclusive and complementary, mutually exclusive and not complementary, or neither for both. Okay, let's do one more. Let's suppose we do 2 dice, and we're going to get doubles. So you're going to roll doubles on 1 dice, or we want to get a total of 11. So the question is, are they mutually exclusive or not? So how many doubles are there in dice? Well, you'd have 2 2s, 2 3s, 2 4s, 2 5s, 6s, and 1s. So you'd have 1 of each, so there'd be 6 sets. And remember, with 2 dice, we get 36. So you'd have 6 out of 36 doubles. And how many are 11s? 5 and 6, or 6 and 5, so you'd have 2 out of 36. Is there any overlap? In this case, no. You can't have a double and a total of 11. So we'd say not mutually exclusive and not complementary again. Okay, let's try one more. So let's suppose I give you, let's say we want hearts. So we're going to draw 1 card out of a deck. What's the chances it's hearts or a 5? So is there, actually let's do, instead of doing that, let's do hearts or diamonds. Okay, is there any overlap? No. You could either have hearts or diamonds. Those are totally separate. So we'd say those are mutually exclusive, but we'd say they're not complementary because if you don't get a heart, it doesn't mean you have to get a diamond, right? You could get a spade or a club or something like that. Okay, so that's good enough for that, just sort of making sure you understand what's the difference between whether they're mutually exclusive or not. In terms of a Venn diagram, let's just do one more quick one. In terms of a Venn diagram, remember the circles have to be separate. So let's suppose I give you a couple different circles here. So the question is, which ones are mutually exclusive? So we'd say A and B are, right? Those are totally separate. A and C are also totally separate. A and D are totally separate. And then the only other one that's separate is B and D, right? Because the C would overlap with the other ones. So that's good enough for terms of mutually exclusive, either making sure you understand the idea of whether there's overlap in terms of the diagram or if it was words. The next type of question that's quite tough to understand is when they give you the probabilities in terms of numbers. So in this question they say the probability of getting A is a quarter, probability of B is a third, and probability of getting A or B is 7/12. And the question is asking, are they mutually exclusive or not? So the only way you can do these ones is to actually use the formula. So I'll rewrite the formula here. So A or B equals A plus B. If they're mutually exclusive, that's all you need. If they're not mutually exclusive, remember we got to subtract the overlap. Okay, so all you basically have to do is check to see if the math works out. So for this question, if you plug in the numbers, so A union B is 7/12. A is a quarter. B is a third. So all you have to do is see if that works. If it does work, then we'd say yes, they're mutually exclusive. If it doesn't, that means we had some sort of extra thing that we had to subtract. So that's all you got to do is just check, in this case, just check the two fractions. So if you go a quarter plus a third, do that on your calculator, that actually equals 7/12. So because the 7/12 equals 7/12, then we'd say yes, they are mutually exclusive. Okay. If it didn't work out, let's suppose the 1/4 plus 1/3 added up to 9/12 or something like that, then that means we would have had to subtract 2/12 or whatever to make it work. And if we did have to subtract, then we'd say they are not mutually exclusive. So any of these questions where they give you the numbers, the probabilities, use the formula to see if you can prove it yes or no. Okay, let's just do a couple more just generic kind of questions. So let's suppose we're going to draw a 1 card out of the regular deck of 52 cards. So the question is, what's the probability we get the 9 of diamonds or a heart? Okay, so what you want to do with these is just basically figure out the probability of each. So what's the probability you get a 9 of diamonds? Well, it's 1 card out of 52. How many hearts are in the deck? 13 out of 52. Is there a 9 of diamonds that's also a heart? No. That means they're mutually exclusive. That means we're done. We just need to add these two together. So we'd have 14 out of 52, and we could reduce that to 7/26, and we're done. Okay, so let's do one more. Let's see, what's the probability of getting a 9? So 1 card again, we get a 9 or a heart. So for a 9, we have 4 9s out of 52. Hearts, we have 13 hearts out of 52. And is there any overlap? Is there a 9 that's also a heart? In this case, yes, there is one, right? So that means it's not mutually exclusive. So we have to subtract that overlap. So we'd have 4 plus 13 is 17, minus 1 would be 16 out of 52. And we'd reduce that, it'd be 8 out of 26 or 4 out of 13. Okay, so you get the idea is just add the two probabilities. If there's overlap, subtract it. If there's not overlap, then you don't. You just leave it the way it is. All right. Let's see if there's one more here. Nope, I think that's good enough. So let's just I'll do a couple more quick ones here for you. So what's the probability we would get a face card or a diamond? So face cards, remember there's Jack, Queen, and King of each. So you have 3 of each suit. So 3, 6, 9, 12, so you have 12 face cards. And diamonds, there's 13 diamonds in the deck. Is there any overlap? In this case, yes, right? We have a Jack, Queen, and King of diamonds. We have to subtract those 3 face cards that overlap. So we'd have 25 minus the 3 is 22. So 22 out of 52, that'll reduce to 11 out of 26. Okay, let's do one more. Let's do the probability of a queen. So what's the probability you get a queen or we get a jack? So queens, we had 4 out of 52. Jacks, we have 4 out of 52. Is there an overlap? Is there a card that's also a queen and a jack at the same time? No. So that means they're mutually exclusive. So we just have to add the 2. So 8 out of 52 would be 2 out of 13 once we reduce it. So the key with this, you can see the math is pretty much the same for all of them. You just have to decide if they're mutually exclusive. So the first one was, and the last one was, so we just had to add the 2 and we were done. If they're not mutually exclusive, the 2 middle ones were not, and that's where we had to subtract the overlap. So when you're doing these questions, that's your biggest decision is there overlap, yes or no? If there is, make sure you subtract it. And that's it.